Ever notice how your phone screen's like a mini sun when you're scrolling in the dark?
Yeah.
It's like this little rectangle just blasting out light waves, And it makes you wonder, what even is light?
Right.
Well, get ready to dive deep because we're unpacking everything we can about light.
Well, absolutely. Yeah.
From physics textbooks to some surprisingly poetic research papers. And it's more than just what we see. It's
Yeah.
energy, it's waves, it's a key to understanding, well, everything. The universe.
It's true. We totally take light for granted, but it really is like fundamental to our existence.
Okay, so let's break it down a bit. We're dealing with energy here, right? I remember that much from school. But the details are a little fuzzy.
Yeah, no, you're on the right track. Light is definitely a form of energy, and it's part of something so much bigger. We call it the electromagnetic spectrum.
Okay, the electromagnetic spectrum.
That sounds intimidatingly scientific.
It's a mouthful.
What's the best way to wrap our heads around that?
Okay, imagine this. You're scrolling through Spotify, right?
But instead of seeing songs, it's different types of waves. Each one has its own energy level.
Okay.
So that's basically the electromagnetic spectrum. And get this, the light we see, all the colors, it's just a tiny sliver in the middle of this massive playlist of waves.
Whoa, so there's this whole invisible world of waves out there that we're just completely missing.
Yeah, pretty much.
That's kind of humbling.
It is. So you've got radio waves. Those have long, lazy wavelengths.
Right?
They're what carry your favorite podcasts to your ears. Then there are microwaves.
Wait, really? Microwaves exist outside my kitchen?
Oh, yeah. And we're not just talking reheating leftovers.
What else are they up to? I'm very curious.
Well, they're out there, part of this grand spectrum,
Wow.
alongside infrared, which we feel is heat.
Okay.
You've got ultraviolet light, which gives you a tan. And then the really heavy hitters like X-rays and gamma rays.
Okay, gamma rays. Now, those sound intense. What makes them so powerful?
Think of gamma rays as like the hulks of the electromagnetic spectrum.
Okay, that's a good analogy. I get you.
They've got the shortest wavelengths and the highest energy, which means they could even like knock out atoms.
Seriously?
Yeah, they're used in medicine to treat cancer, for example.
Wow.
But they're also blasting through space from exploding stars. Crazy.
That's some serious cosmic energy.
For sure.
But hold on, doesn't all this light, from the chill radio waves to the powerful gamma rays, doesn't it all travel at the same speed?
You're right. That's one of the most mind-blowing things about light.
Yeah.
Yeah, it doesn't matter where they are on the spectrum. Every single wave travels at the speed of light, 300,000 kilometers per second.
Wow.
That's like circling the Earth 7 times in 1 second.
1 second.
7 times in 1 second. I can barely grab a coffee in that amount of time.
It's incredible.
Okay, but let's talk about what we can actually see. Color. We all know ROI-GBGV.
The rainbow.
Yeah, the rainbow. But what's the science behind those vibrant hues? Think of color as like our way of perceiving different wavelengths of light. Each wavelength carries a different amount of energy. It's like a cosmic keyboard. And each wavelength is a key producing a unique color.
So each color represents a different energy level of light.
Yeah, exactly.
That's fascinating.
Imagine, a music festival.
Okay.
Red light, that's the chill, laid-back stage. Long wavelengths, low energy.
Gotcha.
Now, on the other side of the festival, you've got blue light. High energy, short wavelengths, intense beats.
That is a great analogy. It's like how blue light can mess with your sleep, right?
Totally.
It's that high energy, that beat that keeps your brain buzzing even when you're trying to wind down.
Exactly.
And speaking of blue, have you ever wondered why the sky is that beautiful azure? What is that?
It's a good question. A lot of people wonder about that.
What's the secret?
What's those shorter, higher energy blue wavelengths we talked about? They get scattered more by the atmosphere. It's like Earth throws a giant blue paint party every day.
Every day.
Yeah, the sunlight hits the atmosphere and boom, blue light gets tossed around like confetti.
So every day is a blue light party in the sky. That's amazing.
It is pretty cool.
Okay, but what about sunsets? What about those fiery oranges and reds? That's a totally different vibe.
That's because during sunset, the light has to travel through way more atmosphere to reach us.
Oh, that makes sense.
And those longer wavelengths, like reds and oranges, they can power through all that air and still get to our eyes.
They're like the marathon runners of light.
Exactly, yeah. They just keep going and going.
It's incredible how much is happening right before our eyes, but we never even realize it. It makes you really appreciate the intricate workings of light.
Definitely.
And how we even see it in the first place. It
Yeah.
feels like pure magic.
It's pretty magical, but there's a scientific reason behind it all. Our eyes have these amazing sensors called cones,
Okay.
and there are actually 3 different types. Each one is designed to detect a specific color of light: red, green, and blue.
So it's like having a little team of specialists in my eyes, each one reporting back on, like, their assigned color.
Exactly. They're like red team checking in, green team we're good.
That's so...
So when all 3 cones are stimulated equally, you see white light.
Like mixing all the colors of paint together.
That's a really good point. And that actually brings up a key difference between light and pigment.
Oh, really?
With light, adding colors together gets you closer to white. But with pigments like paint, the more colors you mix, the closer you get to black.
Oh, whoa. They work in opposite ways.
They do. It's all about whether you're adding wavelengths of light together or subtracting them through absorption.
That's wild. Okay, give me an example.
Okay, so you shine a red, a blue, and a green spotlight on a white wall.
Okay,
It combines to make white light.
that makes sense.
Now, if you mix those same colors as paint, you're going to get muddy brown, closer to black.
Oh, interesting.
Light adds up, pigment subtracts.
Wow, that is a fundamental difference. I never thought about it like that before.
Light's full of surprises.
Clearly. But speaking of how light interacts with things, we see other weird things too, right? Like with mirrors and water.
All the time.
What's going on there? Because 1 minute light's traveling in a straight line, the next it's like bouncing around or bending. It's very confusing.
Those are great examples of reflection and refraction.
Okay.
2 of the ways light interacts with different mediums.
Okay. Refresh my memory on those two.
Reflection is the simpler one. Light bouncing off a surface. So when you look in a mirror, you're seeing light bouncing back from your face.
Oh, right. So it's like lights playing a never-ending game of ping pong.
Exactly. Refraction, now that one happens when light travels from one medium to another.
Yeah.
Like from air to water.
Okay.
And it changes speed and bends. That's why a straw in a glass of water looks broken.
Oh, right. Even though it's not.
Exactly, yeah.
So it's like the light is taking a detour, slowing down for a scenic route through the water.
I like that.
Thank you. This is incredible. Okay, so we've covered so much ground already. The electromagnetic spectrum, how our eyes perceive color, reflection, refraction. It's amazing how much we rely on this invisible force in our everyday lives.
Right.
But what's even more fascinating, I think, is that light isn't just about what we see around us. It's also our key to understanding the universe.
You got it.
Okay, now you're really blowing my mind. We're talking about using light to understand the universe?
Yeah.
How does that even work?
So think of this. When we look at the stars, we're not seeing them as they are right now.
What?
We're actually seeing the light that they emitted like years ago, sometimes millions of years ago. It's traveled across all of space just to reach our eyes.
So it's like we're looking back in time, like a cosmic message from the past delivered by light.
Exactly. And it's not just about pretty stars. Light carries so much information about those objects.
Like what?
Think of it like this. Each beam of light, it's like a fingerprint telling us about a star's temperature, what it's made of, even how it's moving.
So we can analyze starlight and learn about the universe's like past, present, and even kind of predict its future.
Pretty much.
That's incredible. But how can we even see light from something that's so incredibly far away?
Our eyes have limits, right?
That's where the real magic happens.
Yeah.
Telescopes. They're like super-powered eyes.
Okay.
They can gather and focus that faint light from crazy distant objects, and we can see way further than we ever could with just our eyes. And get this, telescopes. They don't just see the visible light we do.
Hold on. Are you telling me there are telescopes out there, like picking up those invisible waves we talked about earlier? The X-rays, infrared, all that?
You got it. They're showing us this whole other level of the universe that's hidden from our eyes. Each type of light, from radio waves to gamma rays, gives us a different piece of the puzzle when it comes to, like, understanding the cosmos.
So it's like we're equipping ourselves with, like, special goggles to see the universe in a whole new light. Literally.
This is blowing my mind. Could you give me an example? What kind of things can we see with these different telescopes?
Okay, let's take infrared telescopes. They can see right through those giant clouds of dust and gas that block visible light.
Really?
It's like having X-ray vision for space.
That's so cool.
They're awesome for observing things like star nurseries, those regions where stars are born.
Whoa, so we're witnessing the birth of stars thanks to light that we can't even see? That's amazing. What about those super powerful gamma rays? What are they telling us?
Gamma ray telescopes. They're revealing some of the most, like, energetic events in the universe.
Like what?
Like supernovas, those mysterious black holes we always hear about. It's like looking at the heart of the universe's most powerful engines.
This is incredible. We're putting together this giant cosmic puzzle using all these different wavelengths of light as clues. It's like the universe is talking to us through this language of light, and we're finally starting to understand it.
You got it. And the more we learn to decode this language, the more we discover about, where we come from, how the universe works, all the mysteries that are still out there.
This has like totally changed how I think about light. It's not just about like illumination, right? It's about information, connection, and unraveling the biggest secrets of the universe. I can't believe we used to think it was just like, what helps us see?
It really makes you think, right?
Totally. It just goes to show you there's always more to discover, even about the stuff we think we understand. And light, with all its complexity, it's the perfect example of that.
Yeah, for sure.
This is making me think about light in a whole new way. It's like we've been handed this amazing gift, this tool to explore the vastness of the cosmos.
And we're just starting to understand how to use it. Every new telescope, every observation brings us closer to understanding where we fit in.
This has been incredible. We've gone from scrolling on our phones to the edges of the universe, and it's all thanks to the power of light.
That's pretty remarkable.
It really is. But now that we've traveled to the edge of the universe and back, I'm thinking, what about light here on Earth?
Oh, absolutely.
What about those everyday examples that we totally take for granted? Yeah, it's kind of funny, actually.
Right.
After that trip to the edge of the universe and back,
Yeah.
It's easy to forget about the light we see every single day right here.
It really is amazing when you think about it. All that stuff, the cosmic stuff we were talking about, it's all happening right here too, shaping our world.
So, where do we even begin? We talked about starlight and everything. But what about just, flipping a light switch?
That's a perfect example.
Yeah.
That seems so simple, right?
Totally.
But it's actually like the culmination of centuries of scientific discovery and understanding how light works.
It's true. Imagine life before the light bulb.
Exactly.
Or think about how we've used light to create fiber optic cables for the internet.
Oh, yeah.
That's insane.
It's completely changed how we live, how we work, how we connect.
And it's not just communication or, being able to see in the dark.
Right.
What about medicine?
Huge.
X-rays, lasers.
It's all light.
That's mind-blowing. We're using light to heal ourselves.
It's a testament to how deeply connected light is to us.
Totally.
But I think it goes even further than that, beyond just those practical applications,
What do you mean?
Well, light has this power to, really inspire us, to move us, don't you think?
Oh, absolutely. Think about art.
Yes.
How light is used to create these amazing effects, like the interplay of light and shadow in a painting or a photo.
Exactly. It's beautiful.
Or even just a laser light show.
Yeah. It's that intangible quality of light, I think, that makes it so fascinating.
It's true. Okay, so we've got the practical uses of light, but then we've also got this emotional artistic side too.
For sure. It can evoke emotions, capture moments, transport us to another place.
It really does feel like light touches everything.
It does.
It's not just science. It's every part of who we are.
Yep.
This has been, I'm not going to lie, this has been a serious eye-opener for me.
Yeah.
I don't think I can look at a light bulb, my phone, even a sunset the same way again.
That's the beauty of knowledge, right?
Mm-hmm.
It changes your whole perspective. You appreciate things more deeply.
We explored the science, the wonder, the straight-up mysteries of light. It's been amazing.
It has. And as we wrap up here, I hope everyone listening will walk away with a little more awe, maybe a little more curiosity about this incredible journey light takes, from a distant star all the way to us.
That's beautifully said.
Thank you.
Okay, so to everyone listening, next time you're in the dark, literally or metaphorically, remember, light is always there.
It is.
Just waiting to be discovered, understood, harnessed.
Keep exploring. Keep asking questions. And never lose your sense of wonder. Who knows what we'll find next?
Amazing. Thanks for joining us on this deep dive into light. We'll see you next time.